Hi everyone. Before I start this video, make sure that you're a part of my Discord server by joining the link in the description box below. And in this video, we'll be going over A-Level Mathematics, May-June 2023, Paper 5-1. This is Paper 5, Probability and Statistics 1, and the total time limit given for this paper is 1 hour and 15 minutes. So in this video as well, we'll be attempting to solve this paper within 1 hour and 15 minutes. Without any further delay, let's get started. A summary of 50 values of x gives summation of x minus q and summation of x minus q squared, where q is a constant. So in this case, n will be equal to 50. We need to find the standard deviation of these values of x. Okay, so first of all, let's find the variance, because variance is just the square of standard deviation. And remember, our usual formula for variance is summation x squared divided by n minus summation of x divided by n whole squared, right? And the formula will not change if there is any subtraction of constant from the variable x, which means that the formula we can use in this case would be summation of x minus q squared divided by n minus summation of x minus q divided by n whole square. So we can still use the formula and get the same variance. Let's substitute the values. We have 14,235 divided by 50 minus 700 divided by 50 whole squared. And this gives the value of 88.7. That's our variance. Now the standard deviation is just going to be the square root of variance. So square root of 88.7. And this results in the value of 9.418. That's the required answer. Let's move to the next part. We are now given the value for summation x. So summation x is just the sum of 50 different values of x, right? And now we need to figure out the value of q. So we can use the given information right here. Summation x minus q equals to 700. We'll solve this equation. Now, if we open the bracket for summation for variable, the summation will still exist. And in this case, x is a variable, right? So we have summation x. That means sum of 50 different values of x. We repeat the same process for q. But remember that q is a constant. So constant will have the same value. So summation q in this scenario will just mean adding the same value 50 times. So rather than writing down summation q, we can write down nq in this case. Okay, so summation x is given to be 2865. N was 50. We need to calculate the value of q. This will be equal to 700. Let's solve this equation. So 50 times q will be equal to 2865 minus 700, which means that the value of q should be equal to 2865 minus 700 divided by 50. This results in 43.3. That's all for this part. Now for question number 2, we need to find the number of ways in which a committee of 6 people can be chosen from 6 men and 8 women if it must include 3 men and 3 women. So in this scenario, we are choosing 3 men out of the total of 6 men. So that's a combination, right? 6C3. And then we are choosing 3 women out of 8 different women. So that's again 8C3, another combination. So this results in the final answer to be 1120. That's all for the first part. Now, a different committee of 6 people is to be chosen from 6 men and 8 women. 3 of the 6 men are brothers. Okay. Find the number of ways in which this committee can be chosen if there are no restrictions on the numbers of men and women, but it must include no more than 2 of the brothers. So the highest number of brothers to be included in this committee is to be 2, right? And there are no other restrictions. Okay, so we have a total of 8 plus 6 people from which we can choose 6 people to form a committee. So that's a total of 14 people, out of which 3 people are brothers. The remaining 11 people, they do not have any relations that we know of, right? And now we need no more than 2 brothers. So we can just divide it into 3 different scenarios. The first scenario is where we have 0 brothers. In this case, we choose 0 out of these 3 people, and we choose all 6 people from the committee out of these 11 people, right? So that is just going to be 3C0 multiplied by 11C6. The next scenario is 1 brother. In this case, we will choose one brother from 3 brothers, and from the remaining 11 people, we will choose 5 different members. And the third scenario is where we choose 2 brothers. So out of 3 brothers, we will select 2, 3C2, and from the remaining 11 people, we will choose 4 members. So 3C0 times 11C6 gives 462. 3C1 times 11C5 gives 1386. And 3C2 times 11C4 gives 990. So the total number of ways is just going to be the sum of these 3 numbers. So 462 plus 1386 plus 990, which results in 2838. That's all for this part. Now for the third question, we need to find the number of different arrangements of the 8 letters in the word cocooned. Okay, so we have 2 repetitions for C and we have 3 repetitions for O. And this is an 8-letter word. We need to figure out the number of different arrangements. We have no restrictions. So the first thing that we do is figure out the factorial of the total number of letters. That's 8 in this case. Now we divide it by the repetitions. So the first repetition we have is for letter C, where we have 2 repetitions. So that's 2 factorial. And the second repetition is for the letter O, where we have 3 repetitions. So 3 factorial. This gives the correct answer of 3360. That's all for this part. Now we need to find the number of different arrangements of the 8 letters in the word cocooned, in which the first letter is O and the last letter is N. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. We already know that the first letter is O and the last letter is N. So we only need to figure out the arrangement for remaining 6 letters, right? So the remaining 6 letters are C, O, C, O, E, D. So we have 2 repetitions for C, 2 repetitions for O, right? So we only consider these letters. That will be 6 factorial divided by repetition of C and repetition of O. This results in 180. That's all for the second part. Now for the third part, we need to find the probability that a randomly chosen arrangement of the 8 letters in the word cocooned has all 3 O's together, given that the 2 C's are next to each other. So whenever we have given that, so we have event A given that event B, right? And in notation, we write it as A given B. We need to figure out this probability. And the formula for these scenarios is always going to be A intersection B, probability of A intersection B divided by probability of B. So what we require in this case is probability of 3 O's together, given that 2 C's are next to each other, which means that they are also together. Okay, and the formula is just 3 O's together and C's together, 2 C's together, divided by the probability of 2 C's together. Okay, let us first figure out the numerator part. Okay, so probability of 3 O's together and 2 C's together. So whenever we have cases with letters together, we just assume that the letter to be together are just one letter. So in this case, now 2 C's will be considered as one letter, 3 O's will be considered as one letter, and the remaining letters in this case is just going to be N, E, D. So 1, 1, 1. So the total letter to be considered is just going to be 5, right? Let's figure out the arrangement. That is just going to be 5 factorial. And we do not have any repetitions, right? Because if you consider only the arrangement of C's itself, that will be 2 factorial by 2 factorial. And if you consider the arrangement of 3 O's, that will be 3 factorial by 3 factorial. So they'll get cancelled out either way. That's just going to be 5 factorial. Now, for the denominator, that's 2 C's together. Now, we do not consider these 3 letters to be one letter. These are still 3 different letters now. So the total letters in this case is just going to be 1, 2, 3, 4, 5, 6, 7. So 7 factorial, and we need to consider repetitions because now the 3 O's are not together. We divide it by 3 factorial. So our required probability is going to be 5 factorial divided by 7 factorial divided by 3 factorial. And this results in the value of 120 by 840, which we can write as 1 by 7. Okay, that's all for this part. Now for the fourth question, a mathematical puzzle is given to a large number of students. The times taken to complete the puzzle are normally distributed. Okay, let us consider the times taken to be x. Then it's a normal distribution with mean of 14.6 minutes and standard deviation of 5.2 minutes. In a random sample of 250 of the students, how many would you expect to have taken more than 20 minutes to complete the puzzle? Okay, so we can break this question into two different parts. The sample given of the number of students is first part, and the second part, probability that one student takes more than 20 minutes to complete the puzzle. Let us focus on the second part first. We can easily calculate the probability of x more than 20 minutes, right? And this is a normal distribution, so we always have to standardize it. And the standardization process is x minus mean divided by our standard deviation. So that is just going to be z is greater than 20 minus 14.6 divided by 5.2. So that will be probability of z greater than 1.038. Okay, and remember that our table will only provide the probability less than a certain value, right? In this case, we require the value greater than 1.038. So in order to figure this one out, what we can do is just subtract the probability less than 1.038 from the total probability of 1. So we can write this down as 1 minus probability of z is less than 1.038. Now we need to look at our formula table. So the value of z that we're looking for in this case is 1.038. Okay. So 1.0 is right here, second decimal place is 3, so that's right here, and the third decimal place is 8, so 19. The required probability is 0.8485 plus 0.0019. This results in 0.8504. Let's get back to our question. So that will be 1 minus 0.8504. which results in 0.1496. So if you round it off to 3 decimal places, that will be 0.150. Okay, and remember that this is just the second part of this question. The first part is that we still have a random sample of 250 students, and now we need to figure out of 250 students, how many would take more than 20 minutes. So we know that one student taking more than 20 minutes has a probability of 0.150, right? So for 250 students, in order to figure out the number of students one would expect to have taken more than 20 minutes, we just multiply the relevant probability. So 250 times 0.150, which results in 37.5. But we're talking about number of people, so we need to round it off as 38. That's all for the first part. Now all the students are given a second puzzle to complete. Their times in minutes are normally distributed. So for second puzzle, let's assume the times is denoted by y. It's again normally distributed with the mean, mu, and standard deviation sigma. And it is found that 20% of the students have times less than 14.5 minutes. So this just means that probability of y less than 14.5 is 20%, which is 0.20. And 67% of the students have times greater than 18.5 minutes. So that's just y greater than 18.5 is equal to 67%, which we can write down as 0.67. Okay, now the next step is to standardize. Let's do that. Probability of z less than 14.5 minus mu by sigma is equal to 0.20. Probability of z greater than 18.5 minus mu by sigma is equal to 0.67. Now we need to find the value of mu and the value of sigma. Let us first draw the curves for both of these equations. Okay, for the first one, the probability less than this value is 0.20. So let us assume this value is a for now. So a is somewhere around here, for this to be 0.20. And let us consider this to be B. And greater than B is 0.67. Remember that half of it is 0.50. So if it's greater, then B must be somewhere around here. And greater than this value is 0.67. Now we can clearly see that both A and B are negative values, right? Because here we have 0 and they both are to the left of 0, which means that they are negative values. Now always remember that our standard normal curve is symmetrical. What it means is, let's see, if A is here, then the opposite sign will be on the opposite side, right? So this will be negative A. Greater than this probability will still be 0.20, which means that the probability less than negative A will be 0.80. And always remember, the formula table only gives the probability less than a certain value of Z. So we need to look for 0.80, that's one probability. Then let us also flip the other curve. So that will be negative B here, where the probability less than negative B will be 0.67. So the two probabilities that we have to look for is 0.80 and 0.67, and we need to figure out the corresponding Z values. Let's do that. So we're looking for probabilities 0.80 and 0.67. Let us first start with 0.80. Okay, so the closest one to 0.80 is 0.7995. If we add another 5 to it, that makes 0.80, right? So the corresponding Z for this one is going to be 0.8, second decimal place is 4, and third decimal place is 2. Now we repeat the same process for 0.67. It's given right here, that's exactly 0.67. So the corresponding Z value is 0.4. Second decimal place is still 4. And we do not have any third decimal place for this one. So the values of Z that we're looking for in this case is 0.44 and 0.842. Let's get back to the question. For 0.8, our corresponding Z value was 0.842. And the corresponding Z value for 0.67 was 0.44. Now, let's write down the relevant equation in this case. Remember that this value of 0.842 is the value for A, but we're looking for negative A. So that means negative 0.842 is equal to this one, because we just assumed this value will be equal to A, right? So that's 14.5 minus mu divided by sigma. We repeat the same process on the other side as well. And in this case as well, Z equals to 0.44 is the value for B, but we're looking for negative B in this case. So again, that's going to be minus 0.44, and this will be equal to this one because we assumed so. That's 18.5 minus mu by sigma. Now, in this case, we have two different variables that we need to figure out, and we have two different equations. So we can easily do so. 0.842, let's bring the sigma to the other side. Sigma will be equal to 14.5 minus mu. Then minus 0.44 sigma will be equal to 18.5 minus mu. Now let's subtract one of these from the other equation. So minus 0.842 sigma equals to 14.5 minus mu. Minus 0.44 sigma equals 18.5 minus mu. We need to change the signs. So plus, minus, plus. Now negative 0.842 plus 0.44 results in negative 0.402 sigma equals to 14.5 minus 18.5 results in negative 4, and negative mu and positive mu will get cancelled out. So sigma is just going to be minus 4 divided by minus 0.402, which results in 9.95. Now we can substitute the value for sigma in any one of these two equations. So let's do so. Minus 0.44 into 9.95 will be equal to 18.5 minus mu. So the value for mu is just going to be 18.5 plus 0.44 times 9.95. This results in the value of 22.878. Okay, that's all. So our distribution for y is normally distributed with mean 22.878 and standard deviation 9.95. Let's move towards the next part. For the fifth question, the populations of 150 villages in the UK to the nearest 100 are summarized in the table. Okay, we have the population 100 to 800, 900. We can see that there's a jump in this case. So it means that we need to make a continuous interval. And whenever we need to make the intervals continuous, we need to figure out the adjustment factor. We start with the lower limit of the second range, or any range for that fact except for the first one. So that'll be 900 in this case, minus the upper limit of the first range, or any range below the one you have taken for your lower limit. So in this case, that will be 800 divided by 2. So that's 100 by 2, which is 50. So our adjustment factor is 50. And in order to adjust your adjustment factor, what you do is you add it to your upper limit, you subtract it from your lower limit. Let's do that. So our new interval is going to be 100 minus 50, 50, 800 plus 50, so 850. Then again, from lower limit, we subtract 50, so 850 to 1250. Then 1250 to 2050. Then 2050 to 3250. 3250 to 4850. Now we need to draw a histogram to represent this information. So whenever we need to prepare a histogram, we need frequency density, right? So our frequency density is just the frequency divided by the class width. And class width is just upper limit minus lower limit for each of these ranges. Okay, so the first thing that we can do is figure out the class width. So we just need to subtract the lower limit from the upper limit. That's 850 minus 50, so 800. 1250 minus 850, so 400. 2050 minus 1250, 800. 3250 minus 2050, so that's 1200. And 4850 minus 3250, so that's 1600. Okay, now you can easily figure out the frequency density. For this one, we just need to divide our frequency, which in this case is the number of villages, by our class width. So 8 by 800 will result in 0.01. 12 by 400 will result in 0.03. 50 by 800 will result in 0.0625. 48 by 1200 will result in 0.04. And 32 by 1600 will result in 0.02. Okay. So now we just have to plot these frequency densities in our relevant ranges or the classes. And always remember that while preparing or drawing a histogram, our x-axis will be the classes and our y-axis will be the frequency density. Okay. Let's start with x-axis. That's the class, which in this case is population. Okay, and the highest population we require is 4850. Okay, and we have 6 blocks. So if we take one block to be 800, that should be enough, but we need to start from 50. So we just have to show that this is 50 and not 0. So 50 plus 800, this one is 850. This one should be 1650. Then it should be 2450. Then it should be 3250 and 4050. Okay. Now let's go over the y-axis. And always remember to use scale so that all of your lines are straight. Okay. This one is the frequency density. And the highest frequency density is 0.0625. So we can consider one block to be 0.01. Okay. Now the first one starts from 50 to 850 and the frequency density is 0.01. So from 50 we have 0.01 till 850. So that's the first block of our histogram. Then the second range is from 850 to 1250, and this range has a width of 400 and our frequency density is 0.03. So 1250 should be halfway right here, and this is 0.03. So our bar should be till 0.03 for these ranges. And make sure you draw the bars with scale as well. Okay, our third range is 1250 to 2050 and the frequency density is 0.0625. Okay, for this one we have till 2050, which is right here, and it's 0.0625, so till here. And it's till here. For the fourth one, it's from 2050 to 3250. Frequency density is 0.04. Okay, so 3250 is right here, and it's 0.04. Okay. And the final one is from 3250 to 4850, and the frequency density is 0.02. So till the end, we now need 0.02. This completes our histogram, but make sure that you use scale so you don't have any wiggly lines like mine. You need to have straight lines. And you can also choose to shade the histogram bars as well. Now for the second one, we need to write down the class interval which contains the median for this information. Okay, I think for median, it's better to list down our intervals. So first one was from 50 to 850, 850 to 1250, I think. Yeah, then 1250 to 2050. Then we have 2050 to 3250 and 3250 to 4850. And in order to figure out your median, we also need the cumulative frequency. Let's write it down. So first class will still have 8. The second class will have 8 plus 12, which is 20. So 8, 20. The third class will have 20 plus 50, so that's 70. Then the fourth class will have 70 plus 48, so that's 118. And the last class will have 118 plus 32, which is 150. So now let's calculate the median. In order to figure out which class contains the median, we first need to figure out n by 2. And the total number of observation in this case is 150. So n by 2 is just going to be 150 by 2, which is 75. So we're looking for a class where the cumulative frequency contains the 75th item, right? So in this case, we can see that this class contains still 70 items. So 75th item will fall in this class right here, because the total cumulative frequency in this case is 118, which is higher than 75. So the required class interval will be 2050 to 3250. All right. Now for the third one, we need to find the greatest possible value of the interquartile range for the populations of 150 villagers. So whenever we're trying to calculate the greatest possible value for interquartile range itself is quartile 3, which is our upper quartile, minus the lower quartile, right? But rather than figuring out the accurate values for our upper quartile and lower quartile, what we do is we take the largest possible value for upper quartile and we take the smallest possible value for lower quartile. And this is for the case when we're trying to figure out the greatest possible value of interquartile range, right? So we're putting as much gap as possible between our upper quartile and lower quartile. If it were the opposite scenario where we had to figure out the lowest possible value, we would be taking the lowest possible value for upper quartile and highest possible value for lower quartile. Okay. The first thing that we need to do is figure out which class contains the upper quartile and lower quartile. So for upper quartile, we can just figure out n by 4 times 1, right? So 150 by 4, which results in 37.5. So 37.5 will be in this class right here. So from this class, we need to choose the largest possible value. And remember, largest possible value is definitely going to be the upper limit, right? But always remember, in our continuous interval data, the upper limit will not include 2050. So it will only include the numbers till 2049. So that will be the largest possible value in this case. All right, now for, oh sorry, this one is for Q1, not Q3. So for Q1, we need to consider the smallest possible value, which is 1250. Now for Q3, that will be n times 4 by 3. 150 by 4 times 3, which is 112.5, and that will be in this class interval. Now the largest possible value will still not be 3250, it will rather be 3249. So the greatest possible value for interquartile range is 1999. That's all for this part. Now for question number 6, Ellie has four fair four-sided dice with sides labeled 1, 2, 3, and 4. He throws all 4 dice at the same time. The random variable x denotes the number of 2s obtained. So probability of obtaining 2 from different 4 sides is just 1 by 4, right? And the number of dice in this case is 4. So this is clearly a binomial distribution. Now we need to show that the probability of x equals to 3 is 3 by 64. Okay, so this one is binomial distribution with n equals to 4, p equals to 1 by 4, right? And for binomial distribution, probability of x equals to r is just going to be ncr p to the power r q to the power n minus r. And always remember, q is always 1 minus p. So 1 minus 1 by 4, which is 3 by 4. Now let's calculate the probability of x equals to 3. According to the formula, that should be 4c3 multiplied by p is 1 by 4 to the power 3 multiplied by q 3 by 4 to the power 1. This results in 3 by 64, which is the required value. That's all for the first part. Now for the second part, we need to complete the following probability distribution table for x. Okay, we need to calculate probability of x equals to 1. Again, we follow the same formula, 4c1 multiplied by 1 by 4 to the power 1, 3 by 4 to the power 3, which is 4 minus 1. This results in the value of 27 by 64. Then for probability of x equals to 2, that will be 4c2 multiplied by 1 by 4 squared multiplied by 3 by 4 squared, which results in 27 by 128. So 27 by 64 and 27 by 128. And we can verify our answer by adding all of these probabilities. It should be equal to 1, which is in this case. That's all for the second part. Now we need to figure out expectation of x, which is basically mean. And expectation of x is just the summation of x multiplied by probability of x equals to x. So we need to refer back to our probability distribution table. That will be 0 times 81 by 256 plus 1 times 27 by 64 plus 2 times 27 by 128 plus 3 times 3 by 64 plus 4 times 1 by 256. Alright, and this results in our expectation of x to have the value of 1. For the next part, Ellie throws the 4 dice at the same time on 96 occasions. Okay, use an approximation to find the probability that he contains at least 2 2s on fewer than 20 of these occasions. Okay, now we have to approximate the binomial distribution to normal distribution, right? And in order to approximate it, the number of occasion is 96. And the probability is at least 2 2s, which means that this should be 2 or greater than 2 as well. So that's 3 and 4. Okay, so that should be 27 by 128 plus 3 by 64 plus 1 by 256. So 27 by 128 plus 3 by 64 plus 1 by 256, which results in 67 by 256. Now let us also calculate the value for Q. That's 1 minus B. So 1 minus 67 by 256. So that's 189 by 256. Now we're approximating it to our normal distribution, right? So for normal distribution, mean should be equal to the mean of our binomial distribution. And the formula for mean of the binomial distribution is NP. So that in this case will be 96 times 67 by 256, which results in 25.125. Then the variance should also be equal to the variance of a binomial distribution, which is NPQ. So 96 times 67 by 256 multiplied by 189 by 256, which results in 18.549. So the new normal distribution has mean 25.125 and variance 18.549. Now the probability that we need to figure out is fewer than 20 of these occasions, so less than 20. Probability x is less than 20. And remember that this is an approximation, which means that we again need to do continuity correction, right? So we're looking at 20, there's 20.5, there's 19.9. And we're looking at less than 20, which means that 20 itself is not included. So we're looking at less than 19.5. Now we can proceed with our normal procedure. So we first standardize it. Z is less than 19.5 minus the mean of 25.125 divided by the standard deviation root under 18.549. And this results in probability of Z being less than negative 1.306. Let's draw the curve. So negative 1.306 is somewhere here, and we're looking at less than. So if we flip the curve, this probability should be equal to greater than positive 1.306. And we can calculate it by subtracting the probability less than 1.306 from the total probability of 1. And we do this because the table only gives the value for less than of positive values, not the negative values. So 1 minus probability of Z is less than 1.306. Now we can look at our table. We're looking for 1.306. So 1.3 is right here. Second decimal place 0 is right here. Third decimal place 6. So that's 10. The correct probability is 0.9032 plus 0.0010. So that's 0.9042. Let's go back to the question. So 1 minus 0.9042, which results in the required probability of 0.0958. That's all for this part. A children's wildlife magazine is published every Monday. For the next 12 weeks, it will include a model animal as a free gift. There are 5 different models: tiger, leopard, rhinoceros, elephant, and buffalo, each with the same probability of being included in the magazine. So we have 5 different possibilities. Same probability is 1.5. Sahim buys 1 copy of the magazine every Monday. We now need to find the probability that the first time that the free gift is an elephant is before the 6th Monday. So before the 6th Monday is first 5 Mondays. So first time should be any one of these Mondays. So we need to add up the probabilities. Let's start with the elephant in first week. So if you get the elephant in first week, that's just 1.5. That's the probability of getting an elephant. Now, the first time getting an elephant in the second week means that in the first week he did not get the elephant. So we need to list down the probability of not getting an elephant, which is 4 by 5. And now he gets the elephant in the second week. Now for the third week, we need to consider the probability of not getting an elephant in the first 2 weeks. So 4 by 5 times 4 by 5. Finally, the probability of elephant in the third week. That's 1 by 5. We repeat the same process for the first time in fourth week. So that's 4 by 5, 4 by 5, 4 by 5. So that's not getting an elephant in the first 3 weeks and finally getting an elephant in the fourth week. And the last scenario is when he gets an elephant for the first time in the fifth week. So that's 4 by 5 times 4 by 5 times 4 by 5 times 4 by 5. So that's probabilities of not getting an elephant in the first 4 weeks multiplied by 1 by 5, which is the probability of getting the elephant in the fifth week for the first time. So we add up these probabilities and get the value of 0.672. That's all for the first part. Now for the second one, we need to find the probability that Sahim will get more than 2 leopards in the 12 magazines. Okay, so this can be considered as a binomial distribution because the total number of weeks we have is 12 and we're considering the probability of getting leopards. So that's 1 by 5. And the probability that we need to figure out is getting more than 2 leopards. So probability of x is greater than 2. And if we consider the greater values, that will be 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's a lot, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So rather than considering these many values, what we can do is we can subtract the probability of getting 0, 1 or 2 leopards from the total probability of 1 so that we get the probability for these values, right? So 1 minus probability of x equals to 0, 1, 2. And again, remember the formula for our binomial distribution is NCR, PR, Q, and minus R. Let's utilize that formula. For x equals to 0, we have 12C0, 1 by 5 to the power 0, 4 by 5 to the power 12. For x equals to 1, 12C1 multiplied by 1 by 5 to the power 1, 4 by 5 to the power 11. For x equals to 2, 12C2 multiplied by 1 by 5 to the power 2, 4 by 5 to the power 10. And this gives the required probability to be of 0.442. That's all for this part. For the third part, we need to find the probability that after 5 weeks, Sahim has exactly one of each animal. So we had tiger, elephant, rhinoceros. We also had a leopard. What was the fifth one? We had buffalo. So we get, so Sahim gets one in each week, right? So the order can be different. So we're basically looking at the arrangement of 5 different letters in this case. We can consider this to be the arrangement of 5 different letters, TERLB. That is equivalent to arranging the order in which Sahim receives these 5 animals. So that is just going to be 5 factorial, right? Now we need to consider the probability. So the probability of getting a tiger is 1 by 5. The probability of getting an elephant is 1 by 5. The probability of getting a rhinoceros is 1 by 5. Probability of getting a leopard is 1 by 5. And the probability of getting a buffalo is 1 by 5. So now we have considered the arrangement, which is the order in which Sahim will receive those 5 animals, as well as the probability of getting those 5 animals. So that's all. The total for this will be 24 by 625. That's the answer we require. That's all for this paper. If you found this video useful, make sure that you like the video and leave a comment below. And make sure you're subscribed to the channel and hit the bell icon so that you do not miss any of these videos in the future. Thank you.